here with Kevin Deerling. Today we're here to talk about the VAST Insights engine with NVIDIA, and there's a lot of big news around what we're announcing today around retrieval. So maybe we'll start by kind of baselining the problem set for everybody and just starting to talk a little bit about how AI models are starting to be augmented with very, very large data sets. So maybe you can just kind of walk us through the market in general.
Yeah, this is exciting. So we've seen a lot of focus with AI on building the models and training. And what we're seeing now is all of the inferencing starting to become important. So we're using the models. And what we find with models, AI models, is large language models actually have some problems. They can hallucinate, they can be out of date, they can share confidential information that you may want to keep private to your enterprises. And so we see things like RAG, which is retrieval augmented generation, solving those problems. And as you say, you augment the prompt using proprietary information that can be current, and you have to be very concerned that that enterprise data only is seen by the people that are supposed to see it to generate new types of information. You're still using the large language model that you've trained, but you're augmenting that now. You're doing fine tuning and obviously vast data. Getting the data, that's a critical part of all of this.
Okay, so there's really a few things. One is the models can hallucinate, and you need the right guardrails. Two is they're out of date because you're only doing model trainings periodically, and then three is you have a certain amount of data that can't make its way into a model. Maybe explain that a little bit more so people understand the sensitivity of data access through LLMs.
Yeah. So as you said, that hallucination problem, when you actually train a model, you train it on a bunch of documents, but all of the provenance, the actual document where the training data came from, disappears. And with retrieval augmented generation, we keep the document and we actually do some embedding. Mm-hmm. So we actually turn sentences and chunks of data and information into numbers. And that's called embedding. And then we vectorize it and index it so that we can search it. And so what is going to happen now is we're going to move from an area which really for the last 25 years, we've been searching for things. Yeah. We're going to find things now. Because when you do a search, you're doing an exact match of these specific words. And grow and increase are not the same words, even though they mean the same thing. And with RAG, we can do semantic search. We can search by the meaning of words. Yeah. And so being able to do that with a vast amount of data store, then we'll be able to find things. So we're going to move from search to find. But you only want to be able to find things that you're supposed to be able to find. So we have this carefully curated set of files that we're able to look through. We need to make sure that that propagates all the way through these new AI inference pipelines like RAG and keep all of that access control intact.
Interesting. So, storage people call those ACLs, right? Access control lists, and defines the policy that you set on top of data access. So we're starting to try to address some of these challenges with the VAST Insight engine with NVIDIA. And here, I kind of think that, as we started to think about our mission and almost our destiny, as you start to think about a distributed data platform that can store and serve all the world's data. Once you get to the point where you can actually go and index that, it becomes a really, really interesting opportunity. And so in some ways, the way that we think about it is you can now fuel AI applications with data in a semantic way, as you mentioned earlier. But on the flip side, AI is the thing that's generating that understanding through embeddings and creating embeddings through different other embedding models that you apply within the system. So, this is a really complex problem for your average enterprise customer to kind of think through and to go and index and kind of semantically align their data to the search tools or the find tools, if I kind of use your words. And so it's a complex problem, but NVIDIA's working to solve a portion of that problem with something called NIMs, right? And so maybe explain what NIMs are for the audience, for those that haven't heard the term.
Yeah, so a NIM is an NVIDIA Inference Microservice. Mm-hmm. And as you talked about, this is complex. The RAG pipeline can be very complex. And so part of the art of what you guys are doing is to make it easy. And the way that you can build these out and scale these things is to actually containerize them. And that's what a NIM does. So there can be an index engine, there can be an embedding engine, a chunking engine, and all of those things can be connected to each other, because one of the things that is absolutely happening is enormously rapid change. Mm-hmm. So the AI space and the inferencing space and the embedding models and the indexing models are changing so fast. And we're adding things like knowledge graphs to a traditional vector index or a vector database. And so regular database, you look things up with columns and we do an exact match. With a vector database, we do a similarity search.
Yep.
Tell me things that are like this. These models are changing constantly. So with the NIM, we can have an API that a NIM can talk to a NIM. These are AIs talking to AIs. You can build an agentic flow that we heard talked about with Jensen and Renan. And that agentic flow of AIs talking to AIs is really easy if we do these in NIMs, because the APIs can be the same, even though the inside of those NIMs is changing, improving all the time. We can re-index things, we can re-embed things, we can do things constantly, and we can do fine-tuning with human feedback. And so all of these things will be happening. It's a dynamic market. The real key is for enterprise, has to be easy. If it's not easy, you can't use it.
And secure. We'll come back to that one in a second.
Absolutely.
So that's the interesting thing. When I talk about Destiny, you think about this system, which is a massive data store that can now start to index itself. Well, that tuning and that retraining that you referred to, that puts a toll on top of kind of legacy infrastructure. And this is where we're really excited to kind of have a purpose-built architecture that was designed in the era of AI now being used to basically derive semantic understanding from data using AI tools that kind of work in harmony with this AI-ready data platform. And last year at our event that we called Build Beyond, we went and announced that this thing is far more than storage, right? And so it has database infrastructure, which becomes the underpinnings for how we do things like store and retrieve embeddings. But it also has a runtime. And so this becomes really interesting because as we think about the graduation of VAST to start to become this OS for artificial intelligence, I kind of think about the index engine and the NIMs that will be running inside our system with NVIDIA almost as the first app in an app store that we'll be bringing to market together. And so that's really exciting for me. And what we want to do is we want to reduce the amount of decision points that customers need to make and kind of start to bring the semantic context out from the native data stores themselves that sit across the enterprise.
Yeah. So what I think's important there, you talked about a couple of things, but we're really elevating storage from being files or objects or blocks, just storing data. There's a lot that blobs. There's a lot of things that you have to do that well. It has to be reliable. You have to do deduplication, fault tolerance, all of these important things that we've seen developed over the last 30 years with enterprise class storage. But really, you're talking about a data platform.
Yep.
You're elevating that to a new level by incorporating all of these new capabilities. Super important. You mentioned security. We'll talk about that. But really, the ability, you talked about bringing in a database to keep track of some of these things. That's super important. The index and the embeddings, all of that together. And you said it was distributed. Distributed is critical. We're going to have all kinds of different data sources. And so having a distributed architecture is what gives us scalability and the ability to deal with heterogeneous data sources. So it's really trying to build that all into a single integrated system is not the right approach, because inherently the data is distributed. So the way that you're actually disaggregating things and distributing them is absolutely architecturally the right way to approach this.
A lot of that is, by the way, in large part due to the collaboration that we had with the Mellanox team, now the NVIDIA team, that goes back to really 2015 when we first started to understand the power of networks that enabled disaggregation, right? So we, since the early days, been working with NVMe over fabrics, and we can build massively scalable, like web scale computers out of this new networking where you kind of decouple the processing layer from the data layer, and you all the processors in your data center can just have this singular view to one global volume. That that actually, as we started to work on the Insights engine, we realized that there was just a ton of opportunity to solve for actually vector search scaling, right? Because the problem set that we saw in the market, I'd really be interested in your opinion on this, is that today we're dealing with very relatively large vector spaces for small documents, and I think it's a byproduct of the fact that there's not an explicit amount of trust in the embedding models that people use. But you know better than I do that the accuracy and the quality and the utility of these models are improving exponentially every year. And so, how do you think about the need for very, very large vector spaces in the near, not too distant future?
Yeah, so we'll see this change over time. What we see today is that the larger the embedding space you use, the better the recall is. Recall is what its accuracy.
Yep.
So when you go do a search for something and you want to find the exact set of sentences that align to that, the bigger your embedding space is, the larger the numbers are. We can see substantial data growth. You can end up seeing 10x data growth. You start with a gigabyte, you end up with 10 gigabytes.
Yeah.
And so this is something that we're working on to optimize all of that, and also figuring out how best to do things that were easy to do with documents like data deduplication, working on that in a vector space now mathematically. And so all of those things, as you point out, combining now networking and compute and storage all together, at the end of the day, it's still blocks. NVMe over fabrics is the way to deal efficiently with blocks. You guys embrace that from day one. So I think that's really important to build a scalable platform.
And as we looked at the different vector DBs that were being used in the market, what we found is that the index space was constrained to a vector database server's memory. And we've been building with you all kind of web scale memory-like data structures forever. And so now we don't think about it in terms of like millions of vectors that an organization might need over time, but rather trillions, right? In one breath, you have those organizations that are going out and doing things like indexing the internet. We want to build something that's appropriate for that level of scale. But then we think about your average Fortune 100 organization, and they're not sitting on small amounts of data either, right? And so as these embedding models get higher and higher quality, the need for scale is just going to go astronomically large. And here we feel like we're in a really good position thanks to this new architecture that we built for web scale.
Yeah, I think there's sort of a misperception that inference is not going to be a complex problem. If you look at training, it is extremely compute intensive.
Yeah.
It's also data intensive. You're going to start with 10 petabytes or 100 petabytes of data. Well, as you point out, a Fortune 100 company has tens of petabytes of data. It's just the reality of people keeping files and everything else. When you index that, you're not going to be dealing with all 10 petabytes at once. You're going to be dealing with a particular user's data. And you have to do that in order, this is the data he's allowed to look at or she's allowed to look at. So that data is actually really going to put more pressure on the storage, on the memory, and on the networking. The compute is important because training is about throughput. How fast can I finish my training job? Inference, it's really important. Time to first token. I've asked a question. How fast do I get the answer? Enormous pressure on storage, memory, and networking.
So let's kind of take a step back and put it all together. So the Insights engine, basically, the data platform is this real-time data flow computer that now supports NIMs on top of NVIDIA GPUs and nodes that we call G nodes. And so it starts by having a system that can just process on data in real time, right? So data comes into the system and triggers immediately get fired off into the data platform that say, okay, I've got this new data set. Please go running an embedding model against it once it's been chunked, and please add those embeddings into a hyperscale index. And so now you've got this kind of corpus that has been self-indexed, right? And then there are other NIMs, to your point, that run services for re-ranking and for retrieval, such that you can now imagine that a storage system or a data platform can talk to a new set of users in an environment that never existed in the enterprise up until now, which, I think of as agents. I don't know what NVIDIA calls them, but that changes the classical definitions of how we think about where we store all of our data in enterprise, because now you don't talk in terms of protocols, you talk in terms of the models that understand, that have a semantic understanding of the data.
Yeah. So I think you just described what I often call real-time RAG.
Yep.
You're going to be storing the data. And you also talked about, D nodes, which is your data nodes, where you sort of started.
Yeah.
You went to C nodes, which are compute nodes, and now G nodes, which are GPUs as well.
Yep.
So you really talk about that escalation and elevation from a data platform, or really a storage platform, to an enterprise data platform.
Yep.
And ultimately the vision here is that you have enterprise data, files and PDFs and graphs, all kinds of enterprise data. And what you want is enterprise insights. What is in there? I don't know how much of my time I spent. Where is that file? Where did I leave that file? I'm searching.
Even once you have the file, then the question is, where's the thing that I really wanted to know within the file?
Exactly.
Yep.
Exactly. And as we get to multimodal models, so we start to incorporate video, we're going to see all kinds of great things. We just introduced a new NIM, which is a video NIM that actually will annotate videos with text to describe what you're seeing, and then it becomes semantically searchable.
That's the crazy thing. I think the role of NVIDIA in the data market is definitely understated. And if you kind of take a step back and you look across all IT history, there's been two primary types of data in the market. One is you have structured data. Those are the data types that are really easy to ask questions to using tools like SQL. Now, obviously AI comes in and says, we understand SQL and we understand human language so that you can build interpreters. But then you have the rest of the data in the world, which is unstructured, which naturally doesn't identify what's inside of it to different business systems. And so the interesting thing is that the unstructured data that we're creating is something like 20 times larger than the data that we're actually structuring and putting in data warehouses and things like this. And I think it's just so amazing to think that NVIDIA, with GPUs and convolutional neural networks, have made a data type that's been sitting kind of in the shadows that nobody's really understood for the last 50 years, have made it now interpretable and queryable and actionable. In some ways, you could argue that in 3 or 5 years' time, we might not be talking about unstructured data, because it just naturally becomes structured through the process of storing it into these agentic systems. So that's kind of cool. And so we love it because it means that now you can just go and query on everything. But of course, you can only see what you're allowed to see, which brings us to security. So we've been having a lot of conversations about this, right? And if you imagine a system that is just a storage system, that has a certain amount of security provenance that it understands. But the LLMs, to your point, don't know how to chunk ACLs and pull them into the kind of the prompt and response process, right? So this is something that we're really excited for, because what we see is a tremendous opportunity to understand the foundational security and security policy model that's basically instilled in the data at the time of origination and at the time of transformation. And so for us, if you bring together a data warehouse, an unstructured data store, and a vector database, you could have a single unified security model that basically makes it such that you no longer need to worry about the integration of systems, the integration of domain controllers, the integration of a number of different independent entities that usually end up with some sort of challenge that can find you on the front of the Wall Street Journal if you implement it wrong. And these are things that we really worry about when we try to build true hardened enterprise infrastructure. So how do you think about that? How do you think about integration versus kind of like built for or fit for purpose type products?
Yeah. So we actually saw this ourselves. If you take the naive approach and you ingest a whole bunch of unstructured data, vectorize it, index it, it becomes not just searchable, but findable.
Yeah.
You can ask all sorts of questions. And when we took that naive approach, we didn't actually take the ACLs with it.
Yeah.
Everything became searchable. If you actually have a unified platform so that you carry your storage ACLs over into your vectorized vector database ACLs, then that unified platform is really a clean way to keep yourself off the cover of the Wall Street Journal.
I think it's a unified ACL model that we're really attempting to build here. One that there are no independent ACLs. It's all just kind of completely woven together into one thing.
That's the real key. You just described it as when you build a disaggregated, distributed system like that, you achieve inherent scale.
Yep.
So as you add more compute, you're adding more networking, you're adding more storage.
Everything.
Build the whole platform up together. We've added AI now, we've added security, we've added vector search. So building out really this new enterprise data platform that you're announcing today, fantastic.
Well, we couldn't think of a better partner to do it with. And I just want to thank you for all your support and the collaboration and the work that we do together.
Excellent. Well, thank you. It's great to be here, and really excited that you guys are building out something that is going to take enterprise data and convert that into enterprise insights.
Yeah.
That data platform, the VAST data platform, is going to do that.
Thank you.